In this particular screencast, we are going to talk about how to synthesize esters and also how to name esters that we synthesize. So when we talk about esters, these form through a process called esterification. And esterification is just the process of forming an ester. And these can be formed when carboxylic acids are heated with alcohols or phenols in the presence of an acid catalyst. So this looks a little bit like this. So we're going to look at a generic reaction where we have our carboxylic acid, which I'm going to abbreviate as Ca, and that reacts with an alcohol or a phenol. And the important thing here is we have this OH group, and I'm going to have an R prime there. So remember, we have R and R prime. Those just stand for the rest of the molecule. And then we are also going to have an acid catalyst, right? And we're going to heat it up. So these esters will form when a carboxylic acid reacts with an alcohol in the presence of an acid catalyst. Now, when you look at this, what happens is we form water. So the OH here and the H here form water, and then the rest of the molecules link together. And so you end up with R, C double bond O, O, R prime, where this part here is this part here, and this part here is this part here, and then water is formed here. Okay, now when we talk about this, we're going to talk about the ester linkage. This is just the carbonyl, carbon, oxygen, single bond of the ester group. When we look at this, what we're talking about here is this bond right here. Okay, so that's our, when we look at the ester group, that's our bond, that's our ester linkage. So that's our ester linkage of the ester group. Now, let's talk more about that ester functional group. This is a key, this ester functional group is a key structural feature in fats, oils, and other lipids, which we're going to talk about in chapter 18. It's also widely found in fruits and flowers. And like I mentioned on the previous screencast, it's also found in flavorings. And so pineapple is one of the flavorings that's really common with. So let's look at some reactions that can form these esters that are specific. So we talked about a carboxylic acid. So if you take butanoic acid, which is CH3, CH2, CH2, C double bond O, OH. That's our carboxylic acid. And you react it with ethyl alcohol. When you look at this and you're trying to predict the products, it helps to highlight what's going to leave as water. And so this right here is going to leave for water. And then this hydrogen here. So it's the hydrogen from the alcohol and the OH from the carboxylic acid. and they leave and they come over here and they form water. Then the two groups that are left, here and here, you attach them. So we would end up with CH3, CH2, CH2, C double bond O, and that comes from the carboxylic acid. And then we've got O, CH2, CH3, and that comes from the alcohol. Now, the name of this, and we're going to get to naming later, is ethyl butanoate, and it's found in strawberry flavoring. I want to do another example of predicting the products in this type of reaction, and I want to do a ring. So let's have a ring here. And then we have a C double bond O, OH, and then we have the OH group here. And this is salicylic acid. And then we also have the methyl alcohol, which is right there. So when we look at this, again, I like to highlight the OH from the carboxylic acid and the hydrogen from the alcohol, because I know that's going to go and form the water. And then if you look here and then here, those two groups are going to come together. And so that's where I start when I draw these products, is I say, okay, I'm going to draw what's under the purple there. And I'm going to keep the OH, and we've got the carboxylic acid. And then what's in the yellow is what is attached to the carboxylic acid there. And then I make water. So this came from the yellow, and that part came from the purple. So we're combining those two parts. It, like I mentioned, it really, really helps to highlight these as you go along. Now, one of the applications of the esterification process is making polyester. Polyester is found in a lot of different consumer products, and it's just what its name implies. It's polymers made by the esterification reaction. So polyesters are just polymers made by an esterification reaction. So the process that's used for this is an example of a condensation polymerization, where monomers combine to form a polymer and eliminate a small molecule, which in our case is water. And so what you have here is you have N monomers, and these are just the repeat units of polymers, come together to form a polymer that is approximately the same length as the number of monomers that you start with. And then you get N number of water molecules as well. So some examples of this include reacting terephthalic acid with ethylene glycol, and that gives you polyethylene terephthalate, which is a PET polymer. About 3 billion pounds of polyester PET, which is right here, is produced annually. And these are things that are used in like automobile tire cord and permanent press clothing. It's used for sutures and woven fabric. So this is used in clothing, tires, sutures. I'm trying to think of what else it's used in. And so there's a good summary of an example of the esterification reaction that is used on an industrial scale. Now, one of the things that's unfortunate about using a carboxylic acid is sometimes these reactions are not as reactive as we would hope. And so we use more reactive carboxylic acid derivatives. And those are things like a carboxylic acid chloride. When we look at this, the way you identify a carboxylic acid chloride is it's got a C double bond O with a Cl. These are also sometimes called acyl chlorides. Okay. And then we have a carboxylic acid anhydride, and these have two carbonyl groups, and in between those is an oxygen. These produce esters in very good yields. And they produce esters in arguably better yields than carboxylic acids. And they're more reactive than carboxylic acids. And they react vigorously with alcohols in a non-reversible manner. And so that's one of the reasons why they are so good at producing these esters. And so let's look at an example of an acid chloride. So we're going to look at a generic reaction first, where we have the acid chloride here, and it's going to react with an alcohol. And then what's going to happen here is, instead of forming water, the hydrogen here reacts with the chlorine here to form the acid hydrochloric acid. Then we get this part of the molecule and this part of the molecule combined. And so now we've got the R, C double bond O, and the O and the R prime. And so those two parts of the molecule have come together. So let's look at an example of this, a specific example. So we're going to react acetyl chloride with ethyl alcohol. And again, I like to highlight what's going to react away. So that's going to form HCl. So that's the first step of solving this problem. And then I look and I say, that means that this and this part have to combine. And so now I'm going to have a CH3C double bond O and an OCH2CH3. And while we haven't done our naming yet, an example of this is called ethyl acetate. And so that's the ester we form. So this is the way that carboxylic acids react, very similar to the way carboxylic acid chloride reacts, very similar to the way that the carboxylic acid reacts. It's just, instead of making water, now we're making HCl. Let's look at how carboxylic acid anhydrides react. So when these react, we're going to look at the generic reaction here. Okay, this is a little trickier. So when we look at this, what we have happening here is that the hydrogen here will react with this part of the molecule there to form this. Okay, now it's just flipped. So basically what we do is we come in here and we draw a line right here, right? And we're going to split those two molecules. Then this part here and this part here combine to form that part of the molecule. So when we look at a specific example, and we have CH3, C double bond O, O, C double bond O, CH3, and phenol, which is this molecule here. The way that I do this is I say, all right, hey, look, I'm going to split this molecule in half, right like this, okay? And then I know that the one that has the oxygen is going to go and form the carboxylic acid over there. And then we have CH3, C double bond O, and that is going to form, and that's a terrible cyclohexane there, that ring there, right? So when we look at this and look at the separations, we have this right here, and then we have this right here, and they formed, and then this and this right here have formed that molecule. So it's a little complex. Highlighters are definitely helpful, but these are ways that we can form esters. Now, I'd love for you to try this particular reaction on your own. When we look at this and you go through and you form these esters, you know that you're going to form water, and it's already highlighted in blue there. And then you put the other two pieces together, where we have the CH3, C double bond O, and then we're just going to fill in this group here. So we flip it around and we make sure the oxygen is attached to that carbonyl. So that would be an example of a problem that you may encounter. Let's do another example. So here we have this particular example. When I come here to do this again, I am going to always kind of draw a line right here. It just helps keep me organized. And then what I'm going to do is I'm going to say, okay, look, I know that this part of the molecule is going to react with that hydrogen. And then I know that this and this are going to combine together. So I just start writing, when I'm predicting these products, the CH3, CH2, C double bond O that's there in yellow, and then I put the other yellow next to it. But I start with the oxygen, and then we have the CH2, CH3. And so those are my two yellow components. And then I come over here and I just put a hydrogen on the oxygen where the red line has shown that it's broken, and form two molecules like that. Now I want you to notice this is the ester, and in this case we're also forming a carboxylic acid. So we form some different molecules here. Again, these are very reactive and different ways to form esters. Now we're going to work on naming esters. When you name an ester, there are two parts. So if we look at a generic ester, we have two parts of the molecule. We have the part of the molecule that came from the alcohol, which is right here. And so this came from the alcohol. And then we have the part of the molecule that came from the carboxylic acid. So this came from the carboxylic acid. So when we name these, the first word is the name of the alkyl or aromatic group contributed by the alcohol. Okay, so it's the name, so it will be the alkyl name from the alcohol, and then what will happen is it'll be the carboxylic acid name, but you have the ic acid changed to ATE. So I would like to do some examples using this kind of naming strategy. So let's name okay. So the very first thing you need to do is you need to identify what part comes from what. And the best way to do this is to draw a line between the carbonyl of the ester and the oxygen, because everything on the oxygen side here comes from the alcohol, and then everything on the other side comes from the carboxylic acid. So when we go to name this, we look at this and we would say, hey, look, that alkyl group is a methyl group. So we would say it's methyl, it's got one carbon. And then we go and look at the carboxylic acid and we would say, hey, look, if that carboxylic acid, if that CH3, C double bond O, was a carboxylic acid, we would name it ethanoate. And so that then becomes the second name, ethanoate, just like that. Let's look at another one. Let's look at one with a ring. A little more complex. Okay. When we look at this, again, I like to draw a line. And that helps me recognize, hey, look, this comes from the alcohol. And that right there is a phenyl group. Then this here comes from the carboxylic acid. And if that was a carboxylic acid, that would be butanoate. And so the name of this is phenyl butanoate. Let's do another example where the benzene ring is on the other side. Again, I come here and I draw my line and I say, look, that comes from the alcohol. So we give that the alkyl name. That would be ethyl. This part here comes from the benzyl group, comes from the carboxylic acid group. And if that was a carboxylic acid, it would be called benzoic acid. And so we drop the ic acid and we say, hey, look, that's benzoate. Okay. And over here, it occurred to me, that's one of the reasons I stuttered, is I made a small mistake. This would be here, ethanoic acid, which is why it becomes ethanoate. I may have said that, but I definitely didn't write it. So ethanoic acid there becomes the ethanoate there, and then the benzoic acid is where we get that benzoate derivative there. So we will do many more of these in class, so this will be part of our class activity. But as always, if you have any questions, please feel free to stop by my office. I'm more than happy to help.